China just changed the game. A structure so vast, so technically advanced, that it has rewritten what modern construction means. For years, the United States defined engineering power: the Hoover Dam, the Golden Gate Bridge, the skyline of New York. Those symbols stood for progress. But that era has faded. What China has just unveiled is not nostalgia. It's proof that the center of global engineering has moved. At a time when most countries are repairing what they once built, China is building what the world thought impossible. The new megastructure isn't another bridge or tower. It's a statement of dominance, a message that innovation has a new address. Engineers everywhere are paying attention because nothing this scale has been attempted, let alone finished, in under 3 years. The project stretches nearly 2,890 meters across one of the most unforgiving terrains on Earth. Its main span alone runs 1,120 meters, longer than most entire bridges in Europe. It stands 625 meters above the canyon floor, roughly the height of 2 Eiffel Towers stacked together. That single measurement makes it the highest bridge deck ever built. The air up there is thinner, the winds are harsher, yet it stands firm. Construction began on January 18, 2022. Within just 3 years, by early 2025, the main structure was complete. No delays, no half-built pillars, no years lost to politics. The total cost sits near 283 million US dollars, or over 2 billion yuan. For perspective, most projects of this scale in the West cross the $1 billion mark before the halfway point. The precision and speed shocked even seasoned engineers. Every component was pushed to its limit. The 2 main towers that carry the structures reach 262 meters, roughly the height of an 85-story skyscraper. Workers poured layer after layer of concrete into mountain rock that had never before been drilled at such depth. Each pile had to anchor into solid ground to resist wind speeds that could strip the paint off machinery. When the structure reached the testing stage, engineers lined up 96 fully loaded trucks, nearly 3,400 metric tons, across the deck. The goal was simple: see if anything bends, cracks, or shifts. Nothing did. Every joint, every beam, every strand held steady under pressure. The bridge passed without a single point of failure. Underneath the surface, the system stays alive. Embedded inside the cables are fiber optic sensors constantly measuring stress, temperature, and vibration. More than 400 monitoring nodes feed real-time data to a central system. If one bolt loosens or a strand shifts by even 2 millimeters, the alert goes out instantly. It's not maintenance, it's machine intelligence keeping infrastructure alive. This kind of constant surveillance used to exist only in high-security military structures. Now, it's built into public transport routes. The cables themselves contain load cells that calculate weight distribution second by second. Engineers can track truck movements from a control center hundreds of kilometers away. That's how far China has moved beyond traditional construction. The terrain gave them no mercy. Guizhou Province, where this bridge stands, is more than 90% mountainous. Over 1.2 million peaks carve the landscape, broken by deep gorges and unpredictable weather systems. Every foundation had to be calculated to withstand earthquakes, windstorms, and landslides. Engineers called it building across the folds of the earth. In places like this, a simple miscalculation can collapse an entire project. Yet China completed it on schedule. The team had to use drones to carry the initial pilot ropes across the canyon. That small thread pulled larger cables one by one until a full catwalk hung between cliffs more than 1,400 meters apart. From there, crews suspended each segment by precision-controlled cranes. It was like assembling a jet engine in mid-air. Even the materials went through evolution. The steel cables, each nearly 1 meter thick, were compacted and tensioned with millimeter accuracy. High-strength steel wires, 91 in every strand, were tested for consistency before being lifted into place. The final structure's weight equals that of 95 military transport planes. Every bolt, Every segment, every joint carries an exact mathematical balance. To stand at that height, the bridge needs not just strength, but flexibility. Engineers used aerodynamic deck profiles that let wind flow through instead of against it. The system adjusts dynamically when the wind speed changes, preventing resonance, the same phenomenon that once caused older bridges to twist apart. The final stage was alignment. The main span had to meet perfectly in the center with less than 2 millimeters of error. That precision over a gap of nearly 3 kilometers defies human margin. It was achieved with digital positioning systems synced to China's Beidou satellites. This is no longer manual labor. It's algorithmic construction. Every phase was tracked, analyzed, and simulated through a digital twin model. That model remains active, predicting stress and fatigue decades in advance. The structure doesn't just exist, it communicates with its engineers in real time. 3 years. That's all it took. From the first foundation blast in 2022 to full structural completion in 2025, the entire project moved with the precision of a military operation. For a structure that stretches almost 3 kilometers, rises more than 2,000 feet above ground, and weighs hundreds of thousands of tons, the timeline sounds unreal. Yet it's fact. Western engineers are stunned because similar projects in the US take a decade, sometimes longer, just to clear planning boards. China didn't wait for committees or political battles. The design, materials, logistics, and testing all happened in a continuous loop. Drones carried cables, automated cranes handled the lifts, and digital twin systems kept construction running 24 hours a day. That pace alone separates this project from anything currently happening in the West. The bridge now sits in a class of its own. The deck height of 625 meters dwarfs every American structure in its category. The Royal Gorge Bridge in Colorado, long considered a marvel, stands at 956 feet. The Golden Gate Bridge's deck rises just 220 feet above water. That's roughly 10 times lower than what China just built. It's not just height, it's speed, coordination, and ambition. The Huajiang structure took only 36 months from blueprint to completion. In contrast, the Hoover Dam, an engineering icon of the 20th century, took 5 years with a workforce of 21,000. The difference is the system. China's modern infrastructure network allows parallel work on foundations, materials, and digital modeling all at once. And it's not an isolated case. Across China, construction is breaking scale records on every front. In Chengdu, the New Century Global Center covers 1.76 million square meters, almost 19 million square feet under one roof. It includes shopping districts, offices, hotels, an indoor beach, and even an artificial sun that simulates daylight cycles. That building alone is 3 times the size of the Pentagon. It's part of the same story: size, speed, and control on a level no country has matched. The bridge and the global center together show what China's new industrial model looks like: vertical coordination from state to steel. When a project begins, there's no delay for funding approval or zoning resistance. The machinery, materials, and manpower are deployed instantly. It's infrastructure as a strategy. This kind of momentum carries a message far beyond engineering. Each structure doubles as a geopolitical signal. China isn't just constructing physical networks, it's constructing global credibility. The country can now build in places where others hesitate: mountains, deserts, high-altitude corridors, because the technology and discipline exist to finish the job. While Washington debates repair funds, Beijing is cutting ribbons. The U.S. Federal Highway Administration reports more than 43,000 bridges nationwide rated structurally deficient. The average bridge age is over 40 years. Meanwhile, China builds a record-breaking one almost every year. In global optics, that contrast matters. It shows whose system delivers results. Every major project released from China carries the same unspoken line: our engineering, our pace, our scale. The government doesn't need to say it directly. The results speak. A 3-year completion window where others take 10. A vertical height that crushes old world records. A level of precision where 400 sensors manage microstress in real time. The message is clear: speed is power, and power now lies east. For the US, this shift cuts deeper than comparison. Infrastructure used to define its national confidence. The Hoover Dam symbolized strength. The Apollo program defined progress. Today, those titles belong to others. China's megaprojects are broadcast live, their completion timed with state holidays and media blitzes. Each one redefines what possible means, while American projects stall at budget hearings. The bridge's impact goes beyond national pride. It's already transforming Guizhou province, one of China's most remote regions. Before the structure, crossing that canyon took over an hour by steep, winding routes. Now it takes a minute and a half, 90 seconds to move from one side to the other. That change rewires logistics entirely. Truck routes shorten, delivery times drop, fuel costs fall. Economically, the region is seeing new patterns. Local tourism is climbing as travelers arrive to see the world's highest bridge. New service centers and rest stops are opening along the expressway. Businesses that once depended on provincial roads now operate on a direct line between mountain towns and the coastal markets. What used to be isolation is turning into opportunity. The bridge also plays into China's long-term connectivity map. It's part of a network linking western provinces to the Pearl River Delta, feeding into the country's high-speed transport spine. Each project integrates with others. Bridges feed highways, highways link to ports, ports connect to rail corridors. It's not construction for vanity, it's logistics for control. The shift isn't just physical, it's psychological. When countries see what China can build in 3 years, the perception of global capability changes. Every project challenges the assumption that innovation belongs to the West. Engineers and policymakers in the US now face an uncomfortable question. If China can build mountains into highways in under 40 months, what's holding everyone else back? Even the reaction online tells the story. Western infrastructure forums call it impossible engineering. American civil engineers break down load models to understand how it stayed within stress margins. The answer keeps circling back to one idea: centralized efficiency. No lobbying delays, no fragmented jurisdictions. The system decides, builds, and moves on. The future implications are wide. Reduced travel time from 70 minutes to 90 seconds means trade routes multiply, energy costs fall, tourism rises, and peripheral cities gain traction. What was once considered rural is now strategically connected to China's coastal economy. It's the kind of transformation that shifts entire population maps. And that's just one bridge. Multiply that by thousands of projects across the country: high-speed rails, smart cities, vertical farms, underwater tunnels, and you get the larger picture. China isn't chasing engineering glory. It's securing infrastructure dominance. Every record it breaks sets a new global metric others must match. The question now moves westward. For US planners, engineers, and decision makers, are you watching this? Are you adjusting? Because the world is. Every statistic from this project, height, length, duration, acts as a benchmark that the next American megaproject will be judged against. China has made its statement through concrete and steel. 70 minutes turned into 90 seconds, a dream turned into geometry, a blueprint turned into proof. The bridge doesn't just connect two cliffs, it connects the present to the future.